Hello everyone. In this video, I'm going to talk about my M5 Stick C Plus and my M5 Rover. Um, Previously, I just write the code for M5 Stick to pair with this PS3 microcontroller as I made a video about it before, and I will show it in the M5 Rover. First, I make it print the MAC address of the Bluetooth on the screen. Then you can set the pairing backend on the PS3 controller as we already show you in previous video. So next step, I will plug this into M5 Rovers. See, I'm not going to talk about the detail on implementation as much because it's just a direct modification from the example of M5 RoverC and the example of PS3 controller. So I gonna talk about how it performs in action and problem that I faced with this F5 rover. Let's see how it performs. So when I um, plug the M5 stick on the rover, I just press the button and then the screen turn green indicate we already connect to the rover. So I will show some functionality here. Okay, let's do this stuff. Okay. I forgot to turn it on. Okay. This one is really poor. I will try to set the command to move forward by pressing forward button, and you can see it's already steer to one side. The left and right looks almost fine, but I will show you here. You can see the motor move at different speed. It indicates that the spec of this motor is kind of mixed up. So the speed of each motor is not matched. So it results in the lower steering instead of going forward. I will try it with another rover here. Okay, and turn it on. Okay, this one slightly better, but you can see it moves kind of fast, but yeah, somehow it still want to move to some direction. You can see this this motor. It moves farther than other. You can see, yeah. Even though the build is really compact and neat, but the quality of the product is not that good. So I decided to make my own M5 rover. I just took the PCB from this one. We can do that um, very difficultly because first we need to remove all the mechanism wheel and then we need to desolder the motor so we can pull it out. Everything, I mean the PCB, the body, the chassis, and the motor is interlocked with each other by soldering joints, so it's very difficult to disassemble it without damage it. So I come up with some trick. So basically, I just pull the gearbox out without desoldering it, and then let me show you. Yes, it just dissolves just like this. So when I pull it forcefully, this bottom of the motor will stick to the PCB, but the entire motor and gearbox will come out. So when it's only this cap on the PCB, it haven't interlocked any longer. So I can pull out entire PCB from the lower chassis, and then I will desoldering this off later, which relatively easier than try to desolder each motor and pull out one by one, because you can see everything is closed. We don't have access to the underneath the chassis, make it very difficult and risking of damage the PCB trace, which I already made one. So I learned from this and I just come up with this brute force solution, but it works well. So I just salvage the parts, the PCB, and then I 3D printed entire body based on the PCB dimension, and then I buy new N20 motor. Uh, Actually, I prefer this configuration because you can see it really compact space, and if I can purchase this kind of motor, I can use with the previous chassis. So the thing doesn't change much and it look kind of neat and problem has been solved. But unfortunately, in Thailand, we didn't have this kind of motor in the market right now. So I decided to use the commercially available one, which is just straight sharp gearbox here, and I just like take off the wheelbase with the availability of the motor. So let's see how this one perform compared to original one. This one I just used 300 RPM 6-volt motor. I have another version of 150 RPM as well, but it moves kind of slow compared to this one because it's power from single lithium-ion battery here, which rate about 3.7 to 4.2 volt, which kind of lower than the motor rate voltage, so it not produce fully 300 RPM. But you can see it gives us more consistent move. So in my conclusion, this modification is better than original one. When we have consistent mechanics, it will make our life easier when we attempt to control it. For example, if I just want robot to go straight, I can do it easily when the mechanics of robot is stable, so it doesn't require control effort as much. So if you want to buy this M5 Rover, I hardly don't recommend it because it doesn't worth your time to try to debug it, and it's not friendly to modify or replace. As I mentioned before, is interlock with the soldering joint to the motor terminal. So it's not really easy to work with it. I prefer something like this where I can change everything. I can change motor. I can desolder it really easily without damaging anything. But if you already purchased it and you found the problem like mine, you can try my solution on it. If I know this earlier, I will not buy this thing. It's not that cheap. I will try to just buy this motor and this wheel, and then I will design the PCB driver by myself, which I think it's gonna be more convenient and will have more feature than this one. But yeah, in case of mine, I already purchased it, so I gonna do my best to live with it, to live with it. Okay, you can see, I think it's not as fast as original motor, but yes, it just I just want I just want this. I think the speed of this motor is enough for my application. It's not that slow, but maybe not that racing fast, but at least is moving in uh straight way or some sort. Okay, or you can see each motor will move and stop at nearly identical time. So this is good indication of good hardware. Okay, so this is all for this video. I hope this video will useful for you. So if you have any comment or question, you can leave the comment in the video, or if you want to discuss about the implementation, you can contact me on my Facebook page, which I already provide in my YouTube channel description. Okay, so see you next time.